Business Cal, Topic 7 homework, problem number 30. We're trying to find the intercepts, the extrema, the inflection point, and the end behavior. First, let's find the intercepts. So what I'm going to do is I'm going to take this equation right here, I'm going to put it inside my calculator. Let's turn this on here, and we'll put in x to the power 3 minus 12x. Okay, we'll hit graph. We have intercepts here, here, and here. This intercept occurs between -1, -2, -3, -4, -4, and -3. So I'm going to go second function and then trace and go to 0. And it's asking for the left bound. I'm going to put the -4 for the left bound. And now it's asking for right bound. I'm going to put -3, and that'll be right around this guy. So -3. It's asking me about guessing between these 2 points. Yes, that's about where I want it. And the answer is -3. Let's say 3.5. So x is -3.5 for the x intercept. Alright, next, let's find the next intercept, which should be right here. Second function, trace again, and 0, which is number 2. And this guy is the next intercept. Let's say I'll put in -1 and then +1, and then I'll guess, and I get x equals 0. So it's my second x-intercept, x equals 0, x-intercept. And next will be this guy, which will be about 1, 2, 3, but between 3 and 4 it looks like. So second function, trace, 0, left bound, 3, other bound, 4, the right bound, 4. So right between here, we're looking, guess. And 3.46, let's call it about 3.5. So x is 3.5. Okay, x-intercepts. Okay, we got that out of the way. The extrema. We have to take a first derivative. We get 3x squared minus 12, and we set that equal to 0. Then we solve for x, so I can factor out my 3. This will give me x squared minus 4 equals 0. And then I can factor this into two binomials, x plus 2 and x minus 2 equals 0. X equals -2 and x equals +2. Now, these are my extremas. I just don't know which one is a max and which one is a min, but we'll get that with the second derivative. Speaking of second derivative, the second derivative will be 6x, and this will be 0. I'll set that equal to 0, and this means that x is 0. Well, when I solve my second derivative equal to 0, this is an inflection point. Alright, so I have my x-intercepts, and I have my inflection points. Now I'll take my second derivative and I'll put the -2 in here. This will give me a -12. The negative answer indicates that I'm dealing with a max. So the -2 here is actually a max. The second derivative, when I put a 2 in here, this is going to give me a 12. That's a negative number, so that lets me, sorry, positive number, so this lets me know I'm dealing with a min here. So this right here is a min. Now, the end behavior. My end behavior really doesn't go past -4 and 4, so it just kind of stops right there. So there's no end behavior to kind of look at on this one. But if I were to, yeah, because this doesn't go any further than 4. So you can put g of 4 in here, and it'll be 4 to the third power. Let's see. Let's do a trace here, and put a -4 into the function, and we get -16. So -4 gives us -16. Let's put a +4 in here, and we get +16. So this is what our end behavior is. This is the left side, left end, and this is my right end. Alright, once again, let's take a look at 31. 31, we're going to put this inside the calculator as 2x cubed minus 6x. Let's put in 6x, there we go. and then we're going to graph that. Okay, and I can see my intercepts right there. Let's check out this first intercept. It looks like it's somewhere between, let's see, it looks like -2 and -1. So let's do a second function trace, 0, and put in -2 and -1. And it tells me that it's going to guess. Oh, no sign change. Let's try that again. So maybe that's not between -2 and -1. Let's try -3 and maybe -1. So second function trace, 0, -3, and -1. And I get -1.7. Okay. So x equals -1.7. My next intercept, it looks like it's 0. Because it is 0, because if I put 0 in here, I get 0. And finally, this number here looks like it's somewhere between 1 and 3. So I'm going to type in, for the left bound, 1, and for the right bound, 3. And then I'm going to guess, and it gives me 1.7. Okay, so that's my, these are my x-intercepts. Okay, my derivative will be 6x minus 6. I'll set that equal to 0, and then solve for x. Oh, sorry, 6x squared minus 6. And I'll factor out my 6, which leaves us with x squared minus 1 equals 0. And I'll further factor this into x plus 1, x minus 1 equals 0. And I have solve it to have x equals -1 and x equals +1. Now, my second derivative will end up being 12x. And I'll set that equal to 0. And when you solve, we'll get x equals 0, and this is our inflection point. Alright, so we got our x-intercepts and our inflection point. Let's take the derivative function and let's put the -1 in here. If I put a -1 in here, we get -12. This means that we have a max. So -1 is a max. When I put my 1 in here, we have the answer is 12. So this means that the 1 represents a min. Alright, now let's put -4 into the original function because these are our endpoints. So putting -4 into our function, we get, wow, -104. And this will be our left end. And for the other side, let's put in 4. And I get 104. And that'll be my right end. Okay. Number 32. Alright, number 32. Once again, we're going to put the function into the calculator. And that'll be 2x cubed plus 3x squared and minus 12x plus 1. Okay, we'll graph that. Okay, my first intercept is somewhere between -1, 2, 3, and -4. So second function, calculate the 0. Let's put in -4 and -3 and guess. -3.3. So -3.3 for my first x-intercept. The next one looks like it's between -1 and +1. So let's try that. -1 and +1, and we'll guess. And it gives us 0.85. Let's put that in there. So 0.085. And then finally, one more intercept, which is here. It looks like it's between 1 and, let's say, 3. Second function, trace 0. And let's say 1 and 3. And it gives me 1.75. Let's call it 1.76. And those are my x-intercepts. Okay, now let's start taking derivatives. my first derivative will be 6x squared plus 6x minus 12. Set that equal to 0 and start factoring or solving it for x. So I'll factor out the 6 and I'll get x squared plus x minus 2 equals 0. That factors into two binomials of x times x and 2 times 1. This will be a positive 2 and a negative 1. So x is negative 2 and x is positive 1. Okay, so I don't know, those are my extremas, just don't know if they're max and mins. Let's take a second derivative. And my second derivative will be 12x plus 6. I'll set that equal to 0 and solve for x and get negative 1/2. This will be my inflection point. Now, let's put the numbers here inside. So negative 2 here gives me negative 24, and negative 24 plus 6 will give me, I think, negative 18. I need to check that out, see if that's correct. Yeah, negative 18. So what we're dealing with here is a max. So that's a max. Now let's put the 1 in here, and I'll get 12 plus 6, which is 18. That's a min because it's positive. So this is a min. Okay. Now, if I put in larger and larger values in here, well, I can take a look at my graph itself. My graph keeps rising to the right. So the n value here will be, right side will be positive infinity. The left side will be negative infinity. Okay. And let's see. Number 33, well, we won't do that one simply because we've kind of represented it by all these problems from here, 30, 31, and 32.